Okay, so this is a panel discussion, which actually kind of naturally follows from that last question, which is kind of nice. Although to a point, I'll get to that in a minute. This idea for this panel came about because there was a discussion in the Nanog list right after the last meeting about the relative merits of ATM versus Ethernet versus all sorts of other stuff for building exchange points. Somebody suggested there ought to be a Nanog talk about it, so I naturally volunteered to do the least work possible, which was to moderate a panel and let other people do the talking. So there's some questions that we could talk about here. What should the exchange point providers be building here? Ethernet, ATM, something else? We have some panelists with ideas on that. What is possible with some of the neat new stuff that's coming down the road, the optical domain especially? And then, of course, there's the question of what do the peering ISPs really need out of an exchange point? One thing I don't want to do here, by the way, is talk about the political aspects of peering. Like who should peer with who and why and that sort of thing. That's really beyond the scope of this, so don't ask those questions. At least not of me. Some architectural questions. This is the Ethernet versus ATM one, but LAN can be FIDI or it can be 10 gig Ethernet or whatever. Virtual circuits could be ATM, frame relay, MPLS. They could even be more real circuits like SONET, cross-connect, like in Randy's proposal. So what's better there? Do we want a model where everything is co-located and you talk across the building, or do you want a model where you're peering with people who are not necessarily in the same building as you, across the metro region, for example? And kind of an extension of that is, do you want the exchange fabric to be centralized in one place or distributed among multiple locations? If you distribute it, how do you do that effectively to avoid bottlenecks, for instance? All sorts of cool new stuff. There's cheap dark fiber we can buy now. There's Metro DWDM is reasonable and getting cheaper. There's MPLS, everybody's favorite buzzword. 10 gigabit Ethernet is almost real. OC 192 is almost real, depending on who you buy it from. And then there's this thing called IP over glass or fiber or whatever. How could that be used, if it means anything at all? Some of the questions, can you actually buy the equipment you need to build the exchange out of? Do you care if you're buying something that's coming off the shelf, or are you willing to invest in or try out something from an emerging provider and see how that goes? In terms of reliability, does the industry need 5 nines? This is another Nanog discussion a few weeks ago. Do we really need the 5 nines of reliability, or is the peering architecture overall good enough to survive a reasonable length outage of, say, an hour? And scalability is an issue, of course. How do you grow these things? When the gigaswitch gets full, what do you do next? So I'm going to start off with our panelists giving fairly short talks on the order of 10 minutes each about what's of interest to them in this area. And then we'll have an open discussion, question-answer period after that. The panelists are Paul Vixie from MFN, Bill St. Arnaud from CANARIE, Lane Patterson from Equinix, and Mike Hughes from LINX. And I've also invited Tom to come up and help field the questions later. Try to get some representation from both the ISP world and the exchange point provider world and the research part of the world. So hopefully there'll be an interesting broad view here. So let's see, we decided to go with the order on the printed agenda here, so let me look that up. And according to this, Paul Vixie is first.
Hello, and I want to start by saying that I'm very glad to be here and not talking about spam. It's the first time in a while. Okay, so moving right along. The couple of things we're either doing or thinking about doing at PAIX to take advantage of some of the cool stuff that Steve said on his slide. Excuse me, virus protection. Yeah, we can have that. Okay. I guess you're all going to get it now. So the big data mover inside of any PAIX is the PNI. And what that is a piece of dark fiber or copper that goes through the wiring plant, but basically cage to cage. It has no active PAIX equipment or any telco equipment. It's just two people want to peer, and we provide the media to do that, and then we get the hell out of the way. And we charge a nominal monthly fee for this. The fee doesn't obviously we're not rebuying the media every month, but we are walking the cable plant, making sure that the database is up to date and that the labels haven't fallen off and so forth. So it's a managed service at that level, but it's a low enough fee that we hardly ever hear complaints about people having to pay for monthly fees on PNIs. So one of the things we're thinking about is actually this came out of a discussion with Vince Fuller some years ago, where he didn't necessarily want to have to do full mesh PNI in order to do full mesh private peering, but he really wanted to have either interface or sub-interface per peer for various things like quotas and tracking and whatnot. It seemed to Vince at that time that we were a little bit too open with this whole subnet topology. So after some years of changing switch vendors and learning how to operate VLANs and whatnot, we're finally going to offer a private VLAN service. It may or may not be called the Virtual Network Interconnect because it makes certain people want to cough up a lung when they see that. But what that'll be is a VLAN with exactly 2 ports as members. So this is just a replacement for the PNI, so that you don't have to dedicate a port in order to have a dedicated connection to some other peer. And once in order to do this, we'll have to turn on tagging on your port, and as soon as that happens, you'll find that there are already 2 VLANs out there because we separated multicast into its own VLAN. Yep, could be the end. What does it all mean? I'm sorry, that's the end of my presentation, it looks like. Okay. Well, I suppose I could just reboot now. Never mind. Okay, so the slide I can't show you is called Metro PAIX, and that again takes advantage of some of the new cool stuff that was on Steve's slide. As some of you know, MFN is digging up the street in front of your building for large values of you and building. So we have about 12 cities operational now, and we're digging up about 67 more worldwide and putting in pretty dense metro fiber. So us have as the big selling point of that fiber that you can get point-to-point metro dark fiber, either for your own use or for peering use or anything you want to do. You can buy it from us on a 17-year contract, sometimes less, sometimes more. And once you have it, boy, it's dark fiber. You can either run raw gig E over it, or you can do WDM. You can do anything you want. However, this VNI concept extends pretty nicely there. Sometimes people want to peer with other folks in the metro, but they don't want to buy a dedicated strand to each one, either because they don't have enough bandwidth or they don't have enough ports or whatever their reason. So there's a fairly good chance that PAIX will stick a switch into each MFN city just for the purpose of selling something very similar to what's on this slide, but in the metro area, so that you can either peer with people without dragging your network down to the PAIX. More or less, you can drag the PAIX network to you over MFN's dark fiber, or you can set up a private VLAN between you and them. Now, I want to keep this real short. I have a lot more talks to do, but I will say one of our switch vendors is in the audience today, and he's already heard me say this. The best switch ever made was the Delny. And if I could get a switch vendor to give me a special download that had no routing, no QoS, no quotas, no nothing, just give me a switch with a lot of gigabit Ethernet ports and a backplane fast enough to handle it, that's the one I'd buy. I would preferentially choose a switch vendor based on that feature alone. However, there is no switch vendor who's willing to do that for me because apparently I'd be the only customer. But what I will say is that switches should switch and routers should route, and having either one try to do the other has been an endless pain in my hiney. So another feature we have asked for is to please not learn MAC addresses, or to learn only one. A lot of our customers use a complex layer 2, layer 3 topology to attach to us and to each other. And if enough of them all do this, it's pretty easy for a bridge loop to come around the backside, or for us to see spanning tree from a customer, or see our own spanning tree back from another customer. So turning off all that spanning tree nonsense and only being willing to learn one MAC address per port, and then filter any traffic from that port that does not come from that one MAC address, is something that right now we do manually. We do static configurations, static filtering, static MAC address to port mappings and whatnot. And it would be a little bit easier on us if the customer were allowed to change the equipment on the end of their line on the port that they have on our switch, without having to tell us what the new MAC address will be. However, without that kind of draconian filtering, you will see the periodic meltdowns that have plagued LINX this year and have plagued us in years past. This switching stuff is not robust. It's very delicate. It's designed around the idea that one MIS manager owns the switch and everything that's attached to it. And that does not fly in my environment. And so we need a little bit more conservatism in our design there. It has to be designed around the idea that the other guy is an idiot. No offense to our customers. So that's my presentation. I'm going to reboot this now.
I think Paul's presentation is a nice segue into what I'll be talking about here. For those who aren't familiar with us, we're the Canadian equivalent of Internet 2, and we've been working on next generation optical networks, and one of our current plans is now looking at optical cross connects for next generation IX using optical technology. Now this, first of all, what I'm giving you just a few slides, which is an extract of a 150 slide deck. For people who are interested in a lot more of the technical details and information on the back behind this, please send me an email. Our website's always out of date, so the best way to get the most current thing is send me an email, and I'm glad to provide you more technical information. Since we're a research network, we don't have any real customers, so we can do all sorts of fun stuff, and we don't have to worry about any real-world consequences like scaling and all that type of stuff. So we can play around with some neat things, and so what we're working with is what we call an optical internet exchange. And we're developing a new protocol, or a variant of BGP, called optical BGP, which will allow us to do some interesting things. So what we are proposing to do, and to address many of the issues that Paul brought up, is to build an optical internet exchange point using combinations of dark fiber and DWDM technology. And the key difference, there's a lot of companies out there building optical switches and so forth, but the key difference about our technology is that we're allowing the ports on the optical switch to be controlled by the customer. And those ports act like a BGP proxy to other users, so that we don't have to have anybody in the center managing the switch. All we require is somebody just to provide electrical power to the switch, and all the control is done by the customer, and it looks like a standard BGP. So as Paul was saying, there's lots of dark fiber now being built in cities in North America, and we're buying this dark fiber and deploying what we call coarse wave division multiplexing, which is a much cheaper DWDM. Not for bandwidth, not for fiber relief, which the telcos want to do, but to provide us with large numbers of peerings and direct adjacencies. So you'll have these various ISPs with their multiple wavelengths, and each wavelength's on a port on the switch which they own, the actual optical cross-connects on the port, and then they decide through this variation of BGP who they will directly peer with. And this optical BGP then acts as a proxy, get rid of all these link state problems, assigning IP addresses, loopback addresses, eliminates all those problems, we hope, and will make it much more simpler and to automate the entire BGP process. So it's taking like PeerMaker and adding a bunch of new frills around that to really make it very, very simple to set up direct peering with a whole bunch of ISPs without ever lifting a telephone call. And that's our ultimate objective. So this new protocol is called Optical BGP. We're developing a prototype proof of concept version right now, which we hope to have fully operational in a few weeks. It's just strictly a proof of concept to show and demonstrate some of these things. And then we hope some of the major route vendors are in this room will adopt this and put it in their box, and we'll be their first customer. But essentially, what it does is take that optical cross-connect and make it look like a BGP-speaking router. But it's really a proxy. This process is running back on your main CPU or server miles away, but it allows then to proxy to both sides, link state addresses, loopback addresses, so forth. And so it makes it much simpler for both parties in their config statements to configure a router, get the peering done without having to contact each other. In fact, it can even be done asynchronously, we hope, where you can say, I will peer with ISP A, 2 days later they peer with you, ignoring timeouts for the time being, and the peering will automatically be established. The other beauty of this is that using wavelengths with BGP, it automatically establishes a priori a quality of service path. Very simple. I agree 100% with Paul. Keep seeing all these gig E switches, all these beautiful whistles and bells with QoS and all that. We don't want that. We just want something very simple, and we think this will achieve this. It guarantees you a path because it's a light path. We're using gig E channels, but soon we hope to use 10 gig E channels from one peer to another. So there's no multiplexing of traffic, nothing like that. And we also think it will be a very useful mechanism for exchange and settlement of wavelengths on some future distributed IX architecture. And the other big advantage, which we hope this will allow, is to massive peering. So you may have, say, 150 wavelengths coming from your ISP and allow you to do massive peering with other, say, no-cost ISPs at major peering points across the country. And so we think this is will be a very low-cost, effective method of doing that. As I mentioned, external routers are given control of the specific ports in the ISP, and it acts as a proxy for the peering session between the two routers. And so that proxy router can be controlled by a third party, it can be controlled by one of the entities of the peering relationship. There's a number of interesting architectural models you can look at. As I mentioned, the switch is under development. We hope to demonstrate it at a workshop we have at the end of November. We're also working with some universities in the Chicago area to build a working first optical internet exchange point between university research networks, Abilene, Internet 2, ourselves, and a number of others, SurfNet from Holland, in Chicago sometime next year. There's a business case. Bill Norton has done a very excellent paper on peering issues and so forth by using optical wavelengths, and these wavelengths now are coming down dramatically in price. We think there's going to be more and more compelling business case for doing massive direct peering rather than just default peering or just multi-homing to an upstream transit ISP. We'll see how that happens. I refer you to Bill's paper for some of these details. Target market, we're seeing a lot of communities building dark fiber networks, like Paul mentioned, and who want a switch to exchange traffic. You cannot mesh fiber. It's physically impossible to mesh fiber to 100 sites. But you want to exchange traffic, but you don't want to go back to the old model of having some large aggregator or telco in the middle. And so this is where we first thought of this concept. In Ottawa, we're building something called condominium fiber network linking 26 institutions. And we all said we don't want to go back to the old telco model, no matter how benign, can we build a device that allows us to interchange traffic and peer with each other and with nobody in the middle? That's essentially what we're trying to achieve. We're also seeing a lot of fiber companies now, new types of carriers out there who are only in the fiber business. Metro Media, but there's a bunch of others out there who want to offer a value-added service, and we think this may be one possibility, but don't want to get into the traditional service stack. And finally, there's all the co-location companies like the PAIX, for example, and so forth, where we think this may be a possibility for a next-generation IX capability. So right now, the standard stuff on how you do peering today, but setting up these optical switches will allow you to do direct, no default, but no cost peering, but it looks like BGP. To the end user, simply looks like standard BGP. There's no change in architecture, no new technology, and allows you also to change peers very easily and quickly. So you may, in this example, have now set up direct peering between AS1 and AS4 and bypass AS3, but because it's based on a large AS flow. But at some future date, you may say, geez, my AS flows have changed, or business relationships have changed. I want to peer with AS6. It would be very easy just to change the BGP command, and then the optical paths are set up in response to the BGP peering. Today, networks start the other way around. First, you set up your physical connection, you set up your TCP connection, then you set up your BGP peering. And what we're saying with OBGP, let's just flip that around. Let's first establish the BGP peering, then let that process establish the link connection. Now, again, this is all very, conceptual, very experimental. There's bound to be some pitfalls we don't know. Does it scale? All sorts of issues. But we think it's an intriguing concept, and we'll keep you abreast of how it develops. And if anybody's interested in further information or participating in the development of this protocol, it's actually very, very simple, just a few little new BGP metrics. Please let us know. So thank you.
Hi, my name is Lane Patterson. I'm a member of research staff at Equinix. My first slide is just kind of a list of all the technologies in general, past, present, and future, at exchange points. Connection models as well, where the connection-oriented obviously lends itself to a lot more control and TE with quite a bit of management overhead to do that. Shared media, the most recent being DPT-SRP, for the metro ring, and layer 1, just a basic SONET cross-connect. I think this is pretty self-explanatory as well, applications that we see at exchange points. Multicast, unicast, private and public peering, and then some things that really maybe have some potential to be seen at exchange points but haven't happened yet. So what we're doing, this is kind of our new thing, is we're finally doing gigabit Ethernet at Equinix. We're doing the one big unicast VLAN model with a mix of private VLANs and tagged interfaces being fine too. So Paul talked about that earlier. There's definitely a shared risk when you're on a broadcast domain with somebody on a large VLAN. So you mitigate that in two ways. One is by having policies and enforcing them at exchange points. And the second is with the filters and knobs on your routers and our switch. I think one of the reasons we kind of moved over towards GigE, there's obvious cost and simplicity advantages. But one of the other reasons was traffic control features now make it kind of less onerous to be on a Ethernet switch. There still is an issue I want to bring up, and there's been a lot of debate over MPU, but not a lot of data, so this is kind of my request for people to talk to about data for this. Specifically, of data that is greater than 1500 in the core, what's in it, and what kind of end-to-end applications and characteristics does it represent. there's definitely a path to moving towards bigger MTUs at Gigabit Ethernet. If you're talking about a mixed MTU environment, there's some things that have to happen for that to take place, and that's for hosts, routers, and switches to basically support MTU per tag. And we're not quite there on that yet. This slide is basically things that participants would do on their routers to mitigate some of the issues on a broadcast fabric, and I think it's self-explanatory, and most people are familiar with this. So on our side, there's two things to point out on this slide, and that's some of the improvements coming down the road on spanning tree for millisecond convergence out of the 802.1w working group. And there's one vendor already claiming support for that in their products. The second is the ability to block bridge PDUs on non-exchange point ports, customer ports. And that feature is there already on the one switch that we've looked at. And the last point on this slide is basically there is a lot more ability to add more controls on Gigabit Ethernet switches. When you go down that road to a point, you start to lose some of the simplicity of why you went with a shared VLAN fabric in the first place. And at that point, we really want something that looks like an NBMA model, and that can be point-to-point VLANs with /30s across them. Future Gigi developments, again, this is pretty self-explanatory, except on the multicast side. Right now, for multicast VLANs, we're still doing port flooding to get that multicast traffic across. And with a little bit of intelligence, we can do a lot better. So that's what we're doing, what we're tracking and testing. I'm going to go through these pretty quick. This is more on the future technology stuff. When the OC48 and 192 router ports come out that are channelizable, I think there's going to be some interesting TDM aggregation on the SONET side. And this is just basic layer 1 SONET cross-connect of STS1 or increments thereof. And I think that's kind of interesting because it represents the opposite end of the spectrum from a Gigabit Ethernet environment where you just want nailed-up connections. And to be honest, that's where people do their traffic engineering today on their critical peering links is on private circuits. So I think the digital cross-connect products or the high-speed SONET cross-connect products are there for this today. When the routers are ready, we're going to be testing some of this gear, and I hope to be able to report back to you on the future. We did take a look at sort of the NBMA migration path up from ATM. Even one vendor who said they would be willing to do FRF8, so we could do a seamless ATM frame fabric. So basically on that, there are a couple switches out there that have reasonable numbers of 48 and 192 ports. Your POS interfaces support it today at line rate, frame and cap. And I don't think anyone's afraid of running frame relay in their network, which brings me to my next point, which is LSRs. I think right now they basically need a little bit more momentum, but there's certainly a lot of potential in this area, so we're testing these as well. I think if some of the killer apps kind of take off for MPLS in the interdomain space, there's a real good case for running some LSRs. So we've looked at a couple different models. I don't think any of them are satisfactory yet in the interdomain space. So my last point, optical switching. As Bill already talked about, I think when you get to a certain critical mass of wavelength per customer and dark fiber strand per customer density, these optical switches are very attractive. And one of the reasons they would be attractive is for some of the dynamic signaling that you get over this type of an architecture. I think without that, you've basically got the equivalent of a dark fiber cross-connect. So it's not too exciting without some of the dynamic signaling features that you get out of, say, the GMPLS group. So for today, sort of the practical version of doing wavelength exchange is for people to bring in their own dark fiber and their own DWDMs and do private dark fiber cross-connects. I threw up a slide here on virtual devices, but I think Bill's kind of covered this already. just with respect to exchange points, I think the concepts here are pretty interesting, and it could be anything from sort of the route server RA model to a real virtual device like Bill mentioned. So my last two thoughts are for exchange points, what are the drivers that are really pushing our technology? Today we've got some pretty awesome capabilities in the core, and they have big implications for the interdomain space. It's going to be a pretty exciting ride to see how fast we can burn those wavelengths. And other than just raw bandwidth, I think there's a lot of interdomain services that are kind of waiting in the wings, that are poised to be adopted. And so what kind of boxes will we see to arbitrate those services at exchange points?
Okay, my name's Mike Hughes. I'm the network architect for LINX. If anyone doesn't know me, a bit about myself. Oh, sure. Yeah, hang on. A bit about myself, but first of all, I'm going to start with the cartoon. So, Paul said that he's digging fibre all over the place, and that's what London looks like at the moment. And there's Metromedia in the top right-hand corner. So, okay. But anyway, onto the presentation. Okay, so like I said, I'm looking after the network architecture over at the LINX in London. A little bit about ourselves, about what sort of things are going on exchange points at the moment, potential spaces where new technologies are going to fit in, and how we can use the existing technologies we've already got and extend the life of them and keep using them, because at the end of the day, some of the existing technologies out there do work at the end of the day. I mean, what you are going to hear is I'm probably going to be singing from the same song sheet pretty much as Paul and Bill and Lane have done. You've just heard the four things pretty much the same again. About ourselves, we're a non-profit organisation, 111 members. We operate a gig man in the London area. It's a flat man. It's a single layer 2 network, and at peak load we switch 4 gigabits per second at the moment, and that sort of starts from when the east coast of the States gets up and continues until our workers go home. We're fairly well peered compared to some other exchange points. The peering matrix is public. It's harvested from various routing databases. Whilst it may not exactly echo what peering is at the LINX, it does sort of give an idea of what people are doing. That's publicly available for anybody to go and have a look at. There's a wide mix of member sizes, and it's right from multinationals right up to sole traders. Our member demographic is about 50% of UK ISPs, again from large nationals to small, 30% continental EU, which is dominated by Germany and the Netherlands, and we're seeing an increasing number of US networks coming over to LINX to come and drop traffic with us, and they account for about 15% of our membership now, and we'd like to see more of you. LINX is like I said, it's a flat layer 2 network. We use Extreme and Foundry switches, and they're interconnected with GigE trunks. Some of them are multiple link aggregated, and it's a multi-site exchange point. We use dark fibre at the moment to interconnect the sites, and we just run native GigE LX over that. Longest run we run is about 15 kilometres with no issues. The switched Ethernet makes it very easy to do lots of one-to-many flows. We don't get involved in the peering. Members negotiate their own peering, do their own BGP configs, and we just leave that to the members, and that's the way we like it. As far as exchange point traffic goes, and this is pretty much drawing from my experience working for a JRandom UK ISP that was a LINX member, you'll have a number of large flows, and you can probably count them on both hands. You may choose to move them off into PIs. You may still do them across the common exchange point fabric. And then you'll also have a number of smaller flows as well, and that's pretty much what we found from our experience. what you do find as well is there can be variability in flows, both regulars and one-offs. And for example, the May ATM hasn't catered well for this. I'm sure it will be doing now with Tom talking about introducing a variable bitrate service. I mean, as an example, you could end up you're peering with somebody and you've got to size your VC at 30 megabits just to counter for 30 megabits for 2 hours a day when there's a person on your network who's doing an off-site backup to one of your peers. The rest of the time it may only be 1 or 2 megabits per second. And Ethernet gives you that flexibility. Also, I mean, an exchange point, certainly in the LINX's case, we exist to promote peering, we exist to facilitate peering and make it easy for people. And if the configuration was much more involved, rather than just putting up some BGP sessions and putting up some filters, maybe people wouldn't peer with the smaller guys, just because it's more work. And I mean, you heard in Randy and Alex's presentation earlier, the more configuration you're going to do, the more likely you are to automate, and potentially the more likely you are to screw up as well. So Ethernet gives very simple, easy, one-to-many solutions that are easy to implement. Where can we put new technologies? I see them fall into two fairly broad categories. They're working in conjunction with the incumbent technology and effectively boosting it, or working alongside it and not necessarily replacing it. You know, or should new technologies even replace it? It's a good question. One option of the first type is GIGI over WDM. It reduces the need for actually having to run lots of dark fiber. It's protecting your investment. Can provide extra resilience as well. A number of metro GIGI solutions now are implementing ring-based fiber protection. If anybody was in Jonathan's workshop on Sunday, will have heard something about that. And that will help avoiding having to do things like, say, running spanning tree. So that's quite another interesting thing to keep an eye on. Also, the cost of metro DWDM equipment is coming down. It's becoming more affordable, but I still think it's got a bit of a way to go yet. And then the other thing is potentially the things that would exist in addition, and that's an optical switching platform. So you're more or less running into two sort of ranges at the moment. One like the Sienna core director box, which is a rapid optical cross connect where you can provision services like granularity down to say STM1 level rapidly just by configuring internal cross connects inside the box. Or you're going over to the Sycamore box, which is actually appliances that are aware of things that are happening at the IP level. In both cases, you don't want to fall into the ATM trap of lots of configuration, and you will require more configuration potentially by the IXP operator and by the user. In this area, Bill talking about the optical BGP is very, very interesting because that would certainly help with that significantly. So I think one of the main things to remember is horses for courses. You need to use the right tools for the job, and there's no point going and using something that's totally overcooked but for something that's as simple as Ethernet and it works. And I think there's room for the new stuff to come in and work alongside the old stuff and not replace it. We can take off those bulk flows and put them into the optical domain, where the optical domain is suited to actually handling that sort of level of traffic. And the Ethernet-based technology, we can beef that up using WDM. And then you can actually mean that you don't hit your breakpoints in the Ethernet technology as soon, for example. So one thing we sort of said here, really, I think everybody said this, we like Ethernet, so it's definitely still got a part to play. I will echo the comment from Paul. If somebody wants to go and make a switch that's really simple with just the code on that needs to do the job, I'll buy one. So there is an extra customer for that, Paul. It's easy to manage, it's cost effective, it's flexible, but it's also paradox because the same things that make it good are also its weaknesses at the moment. We're doing things with Ethernet that it was never designed to do, as Paul said. Different administrative domains all on the same Ethernet switch. It's becoming a man on the campus technology and as well as a LAN technology. So we need to probably improve the robustness and the security in the layer 2 network. You need to actually be able to restore and protect your network. It brings me on to the exchange point switching wish list. This started out as a topic at the RIPE-AIX working group, And it's mainly come out of Extreme and Foundry, our vendors, talking to us and saying, we'd like feedback from you guys about what you're looking for. We've broken it down into 3 broad sections. It's not published yet, it's currently work in progress. And we're breaking it into 3 broad sections. There's security and access control, so that's covering things like security and management interfaces, like being able to say, only speak SNMP on this VLAN, which is RFC 1918, and it's filtered, and it's only within my network. Automated detection of the common rule violations. You've seen Lane had a list of the common things you expect people to switch off on exchanges. You could even implement that automatically in the switch. And again, Paul's wish of 1 MAC address per port without having to do manual configuration. Physical wishes, things like how quick the switch will boot. I know one thing, and if anybody does software upgrades here, those 60 seconds waiting for something to boot back up are the longest 60 seconds of your life. So the quicker something boots, the better. And then other things that physical wishes are things like proper hot swapping, that you can pull a management card and the box will just fail over onto the other one straight away, and until the second management card comes up, it'll keep running in the direction that you left it. So mainly what we're doing is we're seeking to improve on extend life for Ethernet in an exchange point. The main area of interest has been scalability and resilience. So we've been talking about things like STP optimizations and security for STP, so that you can disable acting on STP on a port that's actually in a STP domain. Again, so there's not this issue of somebody with a layer 2, layer 3 device being able to actually inject being able to inject STP BPDUs into your STP domain and possibly hijack your STP domain. And then also the .1W optimizations as well to get that convergence time slower. Faster. The other thing as well has been multicast containment. LINX is currently doing some work with Cisco, doing some testing with RGMP. We're running a separate multicast architecture. We're not running it over the main LAN, and that's for a main reason. We want to preserve the stability of the main peering LAN at LINX. So we're actually running a separate multicast architecture, which is allowing us to change the hardware. And for example, we can just do some tests with people that have got Cisco boxes, try RGMP, see how it goes. We're currently sort of talking to Cisco and saying we'd like you to go and push this towards the standards track as well, so that it's cross-vendor. Basically, the big issue is at the moment switches have never been designed in previous times to go and work in the current router-only environment with no IGMP. Other things that people are interested in are intelligent layer 2 forwarding, and this is basically like a MAC layer OSPF. Watching developments on things like resilient packet ring. Again, coming back into the multicast control, what about when people start using IPv6 across exchanges? You've got to control the multicast and the anycast traffic. And also just keeping an eye on developments on the 10 gig E side as well. A bit more about our thoughts about layer 2 intelligent forwarding. Obviously you can't use a layer 3 in an Ethernet-based exchange point. Your switches would have to have as many different routing policies as you have members in one box, which is a bit nasty, so I don't think we're going to do that. The only way of currently managing redundant layer 2 paths is using STP. You're wasting your bandwidth in between the switches. You've got that issue of potential hijack of your STP domains, the slow convergence. Those are the issues that are there, and really you don't want that. One thing we thought of was instead disable the regular learning on interswitch links. You configure it in your switch. The neighbouring switches establish some sort of dialogue and then exchange information about the forwarding tables. Run some sort of, I said STP, I do mean SPF algorithm, and then actually exchange incremental updates. You could even use STP port path costs as some sort of routing metrics as well. We believe it's probably achievable on many of the layer 3 switch router products. I was saying that I'd like something simple, and I still like something simple, but the architecture that people have implemented could make it possible. The first packet in a flow in most layer 2, layer 3 switch routers is processed switched through the CPU, and then the forwarding tables on the card are manipulated by the CPU to allow the fast switching. You're effectively associating a MAC address with the forwarding IP address, so why can't we associate a next hop MAC address with another MAC address? Would people want to use it outside of exchange points? will it be rendered unnecessary by developments such as resilient packet ring? And I mean, has anybody got any interest in actually running some sort of BOF on this, or being involved in a BOF on this? Show of hands, anybody? No? Okay. Fine. The right people are a bit more enthusiastic about it. Basically, rounding off, XPs, we exist to facilitate peering, and just keep it simple. You've got to bear in mind the different sorts of traffic that people are going to put across the exchange, different sizes of flows, different traffic patterns, things like multicast, things like IPv6 that are coming up. Use the right technology, and to be quite honest, you wouldn't necessarily want to go and take all the old technology away that's doing, some of it in some cases is doing a good job, and replace it with something that probably may not do such a good job, but could be new and good. So that's pretty much it. Some references and links, things that I'm following at the moment. What I will do is I'll get this emailed over to Susan so it can go on the Nanog website. So I think probably it's that time for questions. I think, Steve. I'll see you at the Beer and Gear. Cheers.
Mr. Clerk? Yes. All right, so are there any questions? Or should I throw out some? Okay, I'll throw out one question for the panelists here. Is there really a need for the type of rate limiting that we are trying to do with ATM across an exchange fabric? Not so much for outgoing, but for incoming traffic protection. One of the things that made ATM seem desirable to some people was being able to say, I'll peer with you, but you can only send me 10 meg of traffic, or some amount like that. Is that a realistic need, or is it achievable in a non-ATM type fabric? Anybody want to answer that? No? Sure.
I'll talk to that one. I think for what people use exchange point, which is aggregating a large number of peers at slower rates and doing their higher speed stuff with private circuits, there's not a whole lot of need right now for the bulk of it to do a lot of rate limiting. But there are specific cases where you do want to do rate limiting and you want to peel those guys off, and that's where I think having per VLAN shaping and doing sort of a private VLAN is a really good approach.
I don't get very many requests from PAIX customers for rate limiting. We certainly received more than a few for what amounts to private VLAN, where they will do their own rate limiting in their sub-interface, where they have more control over it. But, so, no.
I'd like to also echo what Paul said. We've certainly not had any sort of requirements or demands for that at the LINX, and that's even with the multi-site architecture as well.
Well, anybody else, or shall we go drink beer? Okay.
Woody has a question.
Oh, good.
Your thoughts on the contrast between exchange points like, for instance, Los Angeles and May West, which have been extensively ad hoc bridged off of the main fabric, and some people would say that these have achieved a kind of durability or robustness greater than that of any one commercial provider that might have been associated with them originally, versus the alternative, which on the one hand would be like the ATM maze, and on the other hand the PAIX, right? Both of which are in their way discouraging ad hoc bridging for very different reasons, one hopes. So, a few comments on the contrast between those two models and why we should trust exchange points that don't allow ad hoc bridging off the fabric.
I have never, this is the first time I've ever had somebody say that they thought ad hoc bridging led to robustness of any kind. because what I can tell you is that the lights go on solid green and they just stay there, and then you hit the power switch. And so ad hoc bridging has been a source of nightmares for me.
I specifically am not talking about technical and routing stability. I'm talking about organizational stability. That is, if one Wilshire were hypothetically kind of going down the tubes, but it's bridged over to Marina del Rey, that would provide organizational stability and a kind of feeling of safety for some of the participants. Likewise, 55 South Market versus NASA Ames.
Those weren't ad hoc. Those were actually planned to be that way for a variety of reasons, but in both those cases they were done with the full knowledge of both sides, and a fair amount of shared management of the
Okay, ad hoc was the wrong word then. Is there a reason that we should trust exchange points that do not have that kind of multi-organizational sharing of responsibility?
I would tend to agree, yes. Our next generation network is just essentially a series of IXs, or MEs across the country, and no real layer 3 service. So all of our users, universities, can have direct peerings with many IXs across the country, which they believe will give them greater stability for themselves, and so if any one route goes down, they're not totally affected.
Thinking about this in the context of Ames, which I guess will not be connected to May West forever, we are trying our best to trench over there with dark fiber and put a switch there. And once the dark fiber is there, I'm expecting that Ames will want to put a switch in Palo Alto as well. It's important to realize that this is not the same as bridging May West Ames and May West South Market, simply because there are two different subnets, and it will always be possible to know exactly what you are plugged into and who you should be talking to, which used to be a bit of guesswork when it was sort of done the other way. So, you know, I can understand the desire for organizational stability, but you have to realize PAIX has been sold 3 times, and no one has ever missed a packet because of it.
I really had no particular object for this question. Probably Steve Feldman. Two questions. Yeah. Am I right that gigabit Ethernet is faster than 10 megabit Ethernet?
100 times faster.
100 times faster. Then why are we waiting? Why do we have that?
It's 10 gigabits coming down the horizon.
I see.
Some vendors have not quite shipping products, but it's not quite standardized yet, and nobody's building real standard hardware interfaces. It's going to be 10 gig is going to be really interesting for a variety of reasons, one of which is also that it happens to be the same speed as OC192, which is 10 gigabits. So at that point, you don't have speed trade-offs when you're trying to decide whether to build a path out of SONET or Ethernet. There's other issues like MTU, but that's going to be an interesting convergence point there.
So when do you think we would like to have a NANOG talk about 100 gigabit Ethernet? Is it too soon? Is the next NANOG too soon for that? Or are you interested for the next NANOG? I'd love to have people come up to the mic. Or maybe not. Hi, Randy.
It's just a medium. It's going to be treated just like GigE or it's not going to change the quality of what we're doing in any way. It's not an interesting medium. The SONET change is an interesting medium, right? Electrical power over MPLS was an interesting medium.
Wait, people want to come and talk about their 100... Their what?
If you get some vendors up here, we want to hear from them.
Vendors want to come talk about their products. They always do.
Yeah. Well, let's close. Oh, sorry.
What might be much more interesting would be a session on optical peering technology at the next NANOG.
Did you hear that?
No, actually.
Can you repeat that? The sound is so different up here than back there.
Yeah, well, what we'd like is a session on optical peering technologies and optical switching at the next NANOG.
All right, I'd like to thank the panelists for coming up here.
Yeah, many thanks.